we are going to talk about area inside of a polar graph as well as polar arc length. Okay. I'm going to show you how, you know what? Don't write this second. Will that be okay?
We talk about this in geometry.
The length of an arc is given by S equals R theta. So if we have a circle and I cut a piece of pizza, slice of pizza, bless you. If this is theta, this right here is S. So our arc length is theta times R, I guess. R times theta. That's something that we talked about in Algebra 2 and pre-calculus, okay? So what I'm doing is I am taking some sort of curve and I'm slicing it to where our theta is super duper small, okay? So small that this looks kind of like what? Okay, this sliver is so small that it looks like a triangle. How do we find the area of a triangle? 1/2 base times height. Okay, we're still not writing this down. Now, this is the area of just a little sliver. We are going to have to add a bunch of little slivers together, which means we will have to utilize the concept of integration. You can write this down. So this was like our differential notation. This right here. Without this, the picture might be a good idea. It's a beta because it's going to be an angle.
So much like Josh.
So we're using alpha and beta because those are names for angles. We're not talking about X's and Y's. We're talking about thetas, so angles and R. Like alpha's top, like alpha dog. Really? Oh, just like you guys made it. You know, it's funny because so I have a female husky, and when we used to have 3 huskies and 2 of them were females, and so when we got the second female, they would really fight with each other because they both wanted to be the alpha, right? Yeah. The older one had to kind of submit and like, okay, fine. All right, we're gonna find the area enclosed by 2 + 2 cosine theta. Andre, what sort of graph is this? Okay. What's Mr. Polinci's class being obnoxious? Be good enough for today. It's not perfect. That's not good.
Why is that? You got it.
The cosine of 0 is 1, so 2 plus 2 is 4.
Do you always add A and B together?
Yes.
How do you know how far to go up and down?
It is 2. Yeah. Drawn to scale. Okay. So if I want to find the area inside of all of this, then we are going to have to take 1/2 the integral from 0 to 2 pi, 1/2 r squared. Now, do we have symmetry happening in this graph? So like from 0 to pi, it's the same as from pi to 2 pi. So if you wanted to, you could always go from 0 to pi and double it if you wanted to. Which would you prefer? We won't always have symmetry, and it's not always going to be from 0 to pi. You could have symmetry from pi over 2 to 3 pi over 2 instead. Correct. We'll talk about the loop.
Yeah.
The loop is a totally different ballgame. Just, we'll talk about it later, okay? So let's just, like, since this is our first example, we're just gonna go from 0 to 2 pi, all right? I'm just telling you that the possibility of using symmetry to double it is a thing. You said you wanna go from 0 to 2 pi.
No, it's okay.
Should we vote?
I said 2 pi.
I said 2 pi.
That won't work. Because there's not that kind of symmetry. Okay, so we have 1/2 integral from 0 to 2 pi. 2 plus 2 cosine theta would be 4 plus 4 cosine theta plus 4 cosine squared. No, it's not. This would be 8, wouldn't it? Right? We have a problem. What's our problem? Cosine squared theta is not something we have an antiderivative for. Man, I'm so glad that we went through chapter, is it 7? I realized that it came out funny. Glad we had chapter 7. Was it chapter 7? Stop laughing at me.
We're not laughing.
I'm not.
Belly button.
Haven't you ever seen the commercials where they poke his belly button? Okay. Andre. Cosine squared. I didn't realize the Pillsbury Doughboy was not relevant anymore. What's cosine squared the same as? What's the power reducing formula for cosine squared? I'm asking Andre.
1 plus cosine.
Good job. Never know what I'm gonna do. So do you agree that 4 and the 2 simplified to just 2? So we have 2 plus 2 cosine of 2 theta. Are we okay with that? Okay,
What's the limit pi now?
it's not. I don't know what you're seeing. Because I'm totally seeing 2 pi. Okay. Let's take the antiderivative. Are you okay if we take? No? Okay. Do you want me to combine the 4 plus 2 before we take the antiderivative? Okay. And can we apply that 1/2 also? So 0 to 2 pi. 4 plus 2 is times 1/2. So we have 3 plus 4 cosine of theta plus 1 cosine of 2 theta. Patrick, do you need a drink? Okay. Josh, antiderivative of 3. Dane, antiderivative for 4 cosine theta.
4 sine theta.
Rachel, antiderivative for cosine of 2 theta. Can it be 2 theta? And you said it's negative? Why? Are you sure? Why? Excellent. Okay. So now we get to evaluate this from 0 to 2 pi. We get to. So we have, but actually, like, I'm sort of excited because I see signs in there. And I know that the sign of 0 and 2 pi are pretty nice. So when I throw in 2 pi, we get 3 times 2 pi plus 4 times the sine of 2 pi plus 1/2 times the sine of 4 pi minus 3 times 0 plus 4 sine of 0 plus, yep. So the area inside this cardioid is 6 pi units squared. Now, if you wanted to check this in your calculator, you would not need to be in polar mode. You can be in rectangular, just function mode. Make sure you're in radians, and you could put this into your calculator and you should get the equivalent of 6 pi. I'm not saying that you need to do that right now. I'm just saying that in a calculator situation, you would not need to be in polar mode. Okay. All right, what do I have next for us? Here's our next example. I want the area of 1 petal of this rose curve. Final answer, pi over 3, we're done. It's not that. Anyone want to make a different guess? Nope.
Is it 0?
That was not very good.
6.
Neither of those. Okay. We need to determine where one petal starts and stops. Set it equal to 0. I don't think that 0 is where cosine is 0.
Oh.
Okay. So where is cosine equal to 0? So we have 3 zeros in this rose curve. Pi over 6, pi over 2, and 5 pi over 6 are all of our zeros. Now, when we plot this, we start here. That's our curve. So we can do one of two things. We can take our integral from pi over 6 to pi over 2, because we know that's where one petal starts and stops. Or do these petals have symmetry? Like this petal with itself, like we could cut it in half and it's symmetric with itself. So if we wanted to, Rachel, I know you were going to do this last time. This curve begins out here at 3, 0. So we could go from 0 to pi over 6 and double it if we wanted to. 0 to pi over 6 is half of a petal. What? Did you say no way? You don't want to? You want to go from pi over 6 to pi over 2? Okay, so 1/2 r squared would be 9 cosine squared 3 theta. Are you okay? What's wrong? He's going bowling. He has no patience for this example. He just has to go. So, Josh, we could go from 0 to pi over 6 and double it, or we can do an entire petal which starts at pi over 6 and ends at pi over 2. But they're all the same.
But they're all, yeah.
Yes.
So where would
But
you
yes.
start at if you were doing that, the first petal, but all, would you start it?
Negative pi over 6 to positive pi over 6.
That's just the first one.
We've already started.
Wait, why did you start this?
Not silly.
For the graph, why do you start on the X?
Because when we plug 0 in, the cosine is 1, so we have 3. So at 0 radians, we're out 3. Okay. So we have 9/2 integral from pi over 6 to pi over 2 of cosine squared 3 theta. Cosine. Isn't it always cosine? I heard sign from somebody.
Oh my God.
I wasn't gonna throw you under the bus.
It's okay.
Get up to
Okay.
the sign without sign. The word, what?
Yeah.
Get. Fact, cost. It's called cost.
Don't
That
ever
was
call
just
it
a
that.
And sin caught.
Are we done? Okay, so we have the integral from pi over 6 to pi over 2 of 9/4 plus 9/4 cosine of 6 theta. All right, antiderivative time. We have 9/4 theta plus 9/24 sine of 6 theta. Is that right? Andre, we missed you this morning.
Yeah, I woke up at 7:30 and then Kurt texted me and I was like, I forgot.
Your reminder came in the evening last night.
Did it? Fired? So what?
You got 2 emails.
Oh, I don't take my email. You do?
It's a universal experience.
Put on trial.
We can discuss it. All right. 9/4 times pi over 2. 9 pi over 8. Plus, when we, can you keep your hands to yourself maybe? Thank you. But you also messed it up. When we plug pi over 2 in, what's 6 times pi over 2? 3 pi. Sine of 3 pi? -0, that's what you're gonna say? Uh-huh. Okay. Then we plug in pi over 6. So 9/4 times pi over 6. That would be better. 6 pi times pi over 6 is pi. The sine of pi is 0. What's 9 pi over 8 minus 3 pi over 8?
Just 3 pi over 4.
Yep.
I didn't go to
0 to pi over 6. Yep. Deal though. You decide what's best for you. If you want to use symmetry and double it, you go for it. If you're totally against that, we won't judge you. Anytime you can use 0, it's pretty nice. Because plugging in 0 is easier. So. Okay. Do you remember? Do you remember when we did arc length for, just hold on, just don't write anything down yet, please. Arc length for parametric was the integral of the square root of dx dt squared plus dy dt squared. Well, if x is r cosine theta and y is r sine theta, it's basically a parametric equation. If we do all the math to simplify it, this is what we get. I'm not going to bore you with that because I honestly know you don't care. We have an example. I would write the formula down. Arc length of a curve. Arc length of a polar curve. Okay. Okay, I'll give you r equals 2 plus 2 cosine theta, and you convert that. I would not do that. I don't know. It doesn't work quite that. There are some curves that are way nicer to work with in rectangular form. There are some curves that are way nicer to work with in polar form, like a rose curve. Converting that, like you can't convert that into a rectangular equation. I can't say with 100% certainty, but I sure would not want to try to do it. I mean, we're talking about r equals what, like 5 cosine of 3 theta? You got to get that to x's and y's. Okay. Do we have this written down? Because we're going to do an example of finding arc length. You ready? This is our third example. What? Okay. Now, in your homework and the ones that we've been doing here in class, the areas have been very simple. Tomorrow we'll look at finding like inside of a, like inside the curve, but outside the loop of a loop limaçon. We'll look at, we have a rose curve and a circle. I want outside of the rose, but inside the circle. Okay, we'll look at problems like that. Write this down. All right, what are we working with? Okay, a cardioid where most of it is up, down, left, or right. Yeah. Okay, and I want the length above the x-axis. What? This is what we want to find the arc length for. Okay. All right, so when we are finding arc length, we need dr d theta. What would dr d theta be? Okay, thank you. Cosine theta wasn't a hard question. Okay, be confident. I believe you. I believe you. Now, because we are working with a radical, I'm going to go ahead and I am going to cut this in half to double it so that I'm only working with first quadrant angles in my integral. I'm just really worried about positives and negatives, okay? And I'll tell you why here after a while. So I'm going to go from 0 to pi over 2 and double it. And we have 1 plus sine theta squared plus dr d theta squared. when I take 1 plus sine theta, the quantity squared, we get 1 plus 2 sine theta plus sine squared theta. What is sine squared plus cosine squared? So you're saying that sine squared plus cosine squared is 1, which means, whoops, underneath we have 2 plus 2 sine theta. What good is that going to do? Okay. Do we have an antiderivative for the square root of 2 plus 2 sine theta? And we can't even use u substitution, because if u equals 2 plus 2 sine theta, we don't have anything for our du. Do you see what I'm saying there? Okay. Nope, we're gonna do a trick. What? So first of all, let's take Josh's advice and take out the 2. So if I take out the 2, it's still under the radical, right? So instead of 2 on the outside, I have 2 radical 2 on the outside. Now we just have, yeah. Dang. Sine squared plus cosine squared is 1, and 1 plus 1 is 2. Are you okay with that? Okay. Now, what I'm going to do is I'm going to factor out the 2. But that 2 is still under the radical. So we have 2 radical 2 integral 0 to pi over 2. Okay, so we're good now? Okay, now I want to force a trig identity underneath my radical so that there's no longer a radical. Okay, so I'm basically wanting to force the Pythagorean identity. So if 1 plus sine is underneath the radical, we could multiply by what to force our Pythagorean identity? Nope. 1 plus sine theta times 1 minus sine theta would give us 1 minus sine squared. Yep. Well, we can use the commutative property to rearrange it. Okay. Okay, now here's where we need to take a timeout and have a conversation. So no, this is a pretty intense problem. Can we just we have 3 minutes, people. Go with me. The square root of cosine squared. I want you to think about the square root of x squared. technically the absolute value of x, because negative x squared and positive x squared would be the same. So since we are going from 0 to pi over 2, we know that the cosine is positive, correct? So the square root of cosine squared in quadrant 1 truly is positive cosine. If we were in quadrant 2, we would have to make it negative cosine. And then we do u substitution. Andre says you have to go. We're just dropping like flies, giving up. So u is 1 minus sine theta. Du is negative cosine theta d theta. And then we go from there. Or radical 2 ends up being your answer. I can promise you, you will have one problem on your assignment very similar to this, where I expect you to do it by hand. Now, can you let me finish? Your test will be a combination of non-calculator and calculator. So yes, there will be times where you get to find the arc length with your calculator, okay? But I want you to suffer through this problem by hand on your homework. Yes.
Dude, ask her. You're